Good afternoon to everyone and welcome to Statistics and Probability class, quarter 4 of week 3. So last time, we have discussed when to classify when a test should be a one-tailed test or a two-tailed test. So with that, it must be based on your alternative hypothesis. The way you state your alternative hypothesis will determine whether it is a one-tailed test or a two-tailed test. So again, to determine whether it is a one-tailed test, if the statement is the population mean is greater than the sample mean, then it's a one-tailed test. But if you will state your alternative hypothesis as the population mean is not equal to the sample mean, then it is a two-tailed test. So for this week, actually we have 3 modules to discuss, but I will give you first the first 2 modules because on Monday, I will have an extension of the last topic for my class observation. So for those who wants to attend online, so may I request everyone to attend the class at 10 a.m. in the morning. So I'll be sending the link in our respective GCs. So to continue, the first module that we have for this week is identifying the appropriate rejection region for a given level of significance. And at the end of this session, you are expected to define the critical values, level of significance, hypothesis test, and rejection region. So these are mainly definition of terms. You need to know these terms in order for you to decide at the end of your research when and how to reject your hypothesis. Secondly, you need to identify the critical value when population variance is known or unknown. And lastly, you need to determine the appropriate rejection region for a given level of significance when population is known or unknown and the central limit test is to be used. So if you can still remember, diba, if the population standard deviation is given or is known, then you need to use the z-test. But if the population standard deviation is unknown, t-test should be used. And when your sample size is too large, greater than 30, then you need to resort to central limit test, which in which entails the use of the c-test. So I have here your learning task number 2, in which you must color or shade the region, the required region for green, and the remaining area as red. Okay, so let's have for number 1, if your z value is from negative 1.56 and positive 1.56, so what will be the green part and which one should be the red part? So I have here the normal curve. Okay, so the first thing that you must do is to locate where is the negative 1.56 and the positive 1.56. So assume that this is the negative 1.56 and the positive 1.56 is more than half, diba? In more than half way of 1 and 2. So this is the positive 1.56. And based on the direction, since it's between, so the required region should be shaded by green color. So which one should be the green? Yeah. So this one will be the green color. And those which are not required should be colored by red. Yeah. So these 2 regions, the 2 tails, are the remaining area. Yeah. So that's how we do the first given task. Okay. So for the rest of learning task number 2, so I'm expecting that you will practice answering number 2, which is finding the area to the left of Z equals 2.05. For number 3, to the right of Z, which is equal to negative 1.3 to the right. For number 4, between Z equals negative 1.58 and Z equals 1.58, positive 1.58. And lastly, to the left of Z equals 1.96. So it's for your exercises na lang for numbers 2 to 5. Okay? So with that, let me continue with our main topic for this week. So you know that whenever you'll be a researcher someday, the first thing that you need to do in a research is, of course, collect your sample data. And from that given data, you'll be able to formulate your null and alternative hypothesis. But the question is, when do you reject your null hypothesis? So it's very important to know some important terms like this one, a critical value. So what do we mean by critical value in statistics? It's actually a point of the test distribution that is compared to the test statistic to determine whether to reject the null hypothesis. Or in simple term, critical value is actually the tabular value. And when we say test statistic, that is actually the computed value. So the computed value will always be compared to the tabular value. It also depends upon the test statistic and the significance level. So if the population standard deviation is given, we have to use the z-test, and that's the test statistic. Okay. And then if the population standard deviation or variance is not given, then we need to use the t-test. And the significance level depends on the researcher. If he or she is 5% sure that he will commit a mistake, then he or she will use the 5% level of significance. So the common values of the level of significance are the 0.01, the 0.025, the 0.5, yan, and the rest of the values. Okay. So this is the table for the critical values of the Z distribution. Okay. So if the level of significance is 0.01, and if it is a left-tailed test, remember that if it is a one-tailed test, if the symbol used is less than, then it's a left-tailed test. Okay. But if the symbol is greater than, it will be a right-tailed test. Yan. So we have here the values for each level of significance, the 2.33, 1.96, 1.645, and 1.28. But if it will be a two-tailed test, then you have to resort with this one, okay, with these values. So let's say, for example, what will be your critical value for a left-tailed test with the level of significance at 0.01. So looking at the table, 0.01, you need to consider this. Okay? Since it's a left-tailed test, so what's the corresponding Z value, the critical Z value for that? So it's negative 2.33. Okay? Okay. So let's have the next one. For the next example, say we have a two-tailed test with the level of significance at 0.05. Okay, so at 0.05, look at the two-tailed test and its intersection with the 0.05 level of significance. Then it will be, for the critical value of Z, Z will be equal to positive or negative. Okay, I don't have a symbol for positive or negative. What's that? 1.645. Am I right? I know. At 0.05, it's 1.96. Positive or negative 1.96. Okay? Is that clear? And lastly, what if you have a right-tailed test at 0.025? So at 0.025 right-tailed test, then the value of the Z critical, the critical value of C is 1.96. Positive. So that's how we use the table for the critical values of the Z values. Okay? Okay. So let's continue. How about when it comes to T distribution? Okay. So here's the table for the T distribution. You have there, if it is a one-tailed test, if it is a two-tailed test, remember that if your test is a two-tailed test, then you need to have a alpha divided by 2. Okay? Yan. Okay. And then you have to consider your degrees of freedom, wherein the formula is n minus 1. So let's say, for example, it is a left-tailed test with alpha or level of significance equals to 0.05 and your sample size is 21. So if your n is 21 minus 1, so that will be 20. So where's our 20? Then a left-tailed test, left. So looking at this one, left-tailed test at 0.05. So what's the value of that? So the intersection at left-tailed test or at 0.05 is 1.75. But since it's a left-tailed test, so that means the value of your T must be negative 1.725. Okay? So you need to consider that, whether it is a left-tailed test or a right-tailed test. Okay. Let's have another example. What if you have a right-tailed test with alpha equals to 0.01 and your n is equal to 17? So at 1, subtract 1 from 17. So it will be, your n will be, the degrees of freedom will be equal to 16. 16, and then the intersection of that at 0.01, so that is equal to, yan, so this one po yun. So it's positive, so positive 2.583. So positive because it's a right-tailed test, okay? But what if, for the last example, you have a two-tailed test with alpha equals to 0.05 and your n is equal to 26. So remember that you need to subtract 26 and that will be equal to 25. So where's our 25? Okay, 25. And then alpha, which is equal to 0.05 at two-tailed test. So the intersection is this one. And since it's a two-tailed test, then your critical value for T must be equal to positive and negative 2.060. So I hope you don't have any question with that. Okay, so let's continue with the next slide. Okay, another important term is the critical region or the rejection region. Remember the first time that I have introduced to you the rejection region and the non-rejection region or the acceptance region. Okay, so it's actually the area encompassed by the values not included in the acceptance region. So once you know the critical value, you'll be able to shade the rejection region and the acceptance region in the normal curve. It is actually the area of the tails of the distribution. Okay, so let's have this one. So remember this 3 types of test from a tails standpoint. So if you have a left-tailed test, only has a tail on the left side of the graph. So obviously, that's why it is called as a left-tailed test. So the rejection region must be on the left side only. Okay, but this area will depend on your critical value and your significance level. Okay, so another type if you have a right-tailed test, of course, the shaded region or the rejection region must be on the right side only. And lastly, if it is a two-tailed test, so both tails yan, will have its rejection region. Okay, so the acceptance will be this area only. Okay. Is that clear? Okay. So let's have an example. Okay, sorry for this word. It's a right-tailed test where, what's the symbol? It's the standard deviation. Standard deviation is known and the level of significance is 0.05 and your sample size is 34. So remember that if your population standard deviation is known, then we need to use the z-test. Okay? Z-test will be used. Therefore, we need to know, or we need to use again the critical values of z. So this one po yan. So since our n is 34, so it has nothing to do with the table, but considering that it's a right-tailed test at 0.05 level of significance, then the value of our z, the critical value is 1.645. So that will be the critical value, the 1.645 here in between the 1 and 2. And then the tails, since it's a right-tailed test, so you have the rejection region at the right tail. Okay? Is that clear? Okay. So let's have another example. Example number 2. Meron pa ba? So what if it's a two-tailed test where the population standard deviation is unknown and the level of significance is at 0.05 and sample size is 10. Okay? Knowing that the population standard deviation is unknown, then we need to use a t-test. So t-test will be used. Okay. And what else? So what's the table natin for that? Let's have the table. Let us have the table for the t-test. Your n is 10. So your degrees of freedom will be equal to 10 minus 1. So it's 9. So nasan si 9? Okay. And then at 0.05 level of significance, two-tailed test, the value of our t is positive. The critical value of t is positive and negative, positive or negative 2.262. So after knowing the critical value, the next thing to do is to locate that in your curve. Okay, the 2.262, the negative 2.62, and the positive 2.62 in the curve will be your critical values of t. So since it's a two-tailed test, you will have two tails with the rejection region. Okay, so 2.62, medyo lumagpas kay 2, kaya ito po yung critical value natin. Then the shaded region on both tails. Okay, is that clear for the first module? So I hope so. Okay, let's have the next slide. Okay, which is the second module. And this is entitled Computing or Computation of Test Statistic on Population Mean. And you're expected to determine the appropriate test statistic to be used and then compute for the test statistic value. Okay? And so remember this again and again that you need to use two test statistics in testing hypotheses. If your sample size is quite large, where n is greater than or equal to 30, and the population standard deviation is known, then you need to use the z-test. Okay? But, yan, which has a formula of this, where X bar is the mean, sample mean. This is the population mean, the population standard deviation, and then the sample size. Yan. But if your sample size is quite small, where n is less than or equal to 30, and the population is normal or nearly normal, and the population standard deviation is unknown, then you need to use the t-test with a formula of this one. So only symbols are what do you call that? The symbol for the sample standard deviation. Okay, so that's the only difference. For the z-test, we use the sigma for the population standard deviation, while for the t-test, we used s for the sample standard deviation. Okay, so let's have this example. Compute the z-value given the following information. Ayan na po lahat. So paano ba natin siya i-compute? Meron ba ako dito? Okay. So, since this is the population standard deviation, this symbol, then we need to use the z-test. Okay? So, it's very obvious. So, to solve that, substitute the given values for the sample mean, which is 70, minus the population mean, which is 71.5, divided by the population standard deviation, which is 8, over the square root of 100. Okay, so by using your calculator, 70 minus 71.5 is negative 1.5. So it's negative 1.5 over, so you need first to find the square root of 100, and that will be equal to 10. So for your denominator, you'll have 8 over 10. So that will be equal to negative 1.5 divided by 0.8, right? So by using your calculator, it will be equal to negative 1.5 divided by 0.8 is equal to negative 1.875. So this is actually your computed value. So this is known as the computed value. Okay? And after knowing the computed value, okay, we'll have the next step of that for the next module, which will be discussed on Monday. So since we are just interested in computing the test statistic, then that's all for this week. Okay po? Okay. So that's the value for this example, the z value. Okay. For this example naman, ayan. So obviously, sabi, a sample of 26 families, a sample. So meaning, the values like the mean, the standard deviation, they all came from the sample. Okay? So meaning, ayan, listing down all the given, the population mean will be equal to 100. Am I right? 10,000 pala, sorry. So it's 10,000. Then the sample mean is 10,900. Your N, the sample size is 26. The sample standard deviation is 1,250. So obviously, since the sample standard deviation is given, then we need to use the t-test. Okay po. And what's the formula? So it's the sample mean, which is 10,900, minus 10,000 divided by the standard deviation of 1,250 divided by the square root of 26. Right? Tama ba tayo dyan? Okay. And so, solving for that, 10,900 minus 10,000 is 900, of course, divided by 1,250. Sorry for the writing, for the way I write. Square root of 26 is approximately equal to 5.1. So you'll have 900 divided by the quotient of these two, which is 2.245. So you may use your calculator, 0.1. Therefore, the t value is 3.671. So what is important here for this module is that you know how to use and when to use the z-test or the t-test. Okay? And so if you have no more questions, obviously you cannot ask questions with this recorded video. Okay. So let me present to you your learning task number 3 for this week, which is entitled Find My Value. So you need to determine what test statistic is to be used in each problem. Then you need to find the value of that. So whether it is a t-test or the z-test. So you have here 10 numbers. Yan. So I will also send a hard copy of your module for this week. Yan, 5, 6, 7. Yan. So, just a reminder for everyone, ano po, since this is a math subject, I'm requiring everyone, all problems to have solutions. So not just the answer. Remember that I'm after more of your solution, not the final answer. So with these 10 questions under learning task number 3, hopefully you can show me the solution in your paper or in the document that you will send or save in the G Drive, and then always box your final answer. So hopefully you get something again from this week's lesson. So again, I'm inviting everyone to attend my class observation on Monday at 10 o'clock in the morning. So goodbye everyone. Have a nice weekend.